right, so if we're gonna take a look at graphing this function and finding our key features with a graphing calculator, the first thing I wanna do is I wanna go into my graphing calculator and I wanna type this equation that I'm seeing into my y equals. So I'm gonna go ahead and do that. So here's my calculator, and you can see I've actually already typed it into my y equals here. X times 6 minus 2x times 10 minus 2x. And so now that I have done that, my next step is I'm going to hit the graph button so I can see the graph. And most of the time what we're going to see is it graphed on a window that's from -10 to 10 instead of, whatever we might need to see. So right now I can see that I'm not sure I need to extend my X window anymore because I can already see to the left and to the right that I can see my x-intercepts, but I do need to see higher and lower, so I need to change the y values of my window. So right now my window is going from -10 to 10. I'm going to try going from -20 to 20. Just going to see if that gives me enough of a view. So notice I don't need to go any lower because I can see that bottom minimum, but I can't see that maximum. So I do need to go to my window and I need to go higher. So I'm gonna try going to 30 and see if that allows me to see everything I want. Oh, I'm super close. I'm gonna try again. I'm gonna go back just to be safe. I'm gonna go up to 40. And now I can see my entire function. So that is my first goal, is to be able to see that full polynomial function. So now what I'm gonna do is I'm gonna sketch that onto my notes because that's what I want to be able to see. So I am going to take this, I'm going to draw a little sketch of what I'm seeing here. And I know I won't have a perfect drawing, and that's okay because that's a sketch. Now, I do want to be able to label what these x-intercepts are and what our maximum and minimum, our local max and local minimum are. So that's going to be what I do next. Now, in my calculator, I have tools that will help me find all of those things. The place that I'm going to access them is in this calculate function up here. So to get there, I'm going to second trace. And that gives me these choices. Do I want to find a value? So that's talking about, do I want to find y when x is something? Or do I want to find a 0? Well, right now, that's what I'm going to find first. I want to find my zeros, my x-intercepts. And when it does that, it's going to ask me to find my left bound. So I need to make sure that I am to the left of that 0 before I hit enter, and see how it pulls up that arrow. That means I'm looking to the right of that arrow. And then it says right bound, and I want to make sure I move this little x that we see here to the right of that. And now these arrows are saying I'm looking for a 0 that's between here and here. And then guess means I want to go and try to get approximately to where I think the 0 is. And I'm going to hit enter because that's about where I think it is. And now it's going to give me my 0. So I have one x-intercept here at 0. So now I'm going to repeat the process again twice to find these two other zeros. And you never want to just move your tick mark here because it's not going to be precise. You want to know exactly what that 0 is. So you want your function to calculate it for you. So I'm going to go back into the second calculate menu, and I'm going to go to my second 0. It's asking me for my left bound, so I am to the left of it. I'm going to hit enter. Now it asks for my right bound, so I'm going to make sure I move to the right of it. Notice these two arrows are saying that my calculator is going to look for the 0 between those two spots, so that's good. And then my guess, I need to go put it where I think my 0 is. I think it's about right there. And now it tells me my 0 is exactly at 3. So that has found that exact 0. Okay, now again, beware, we don't want to just try to use this tick mark because we might not be sure we're finding the exact one. So, okay, and then one more time, we're going to find the 0. So now I'm trying to find this third 0. I want to make sure I'm to the left of it, so I'm going to hit enter here. Now it's asking me for my right bound, so I'm going to hit enter here. I see my two arrows. It's telling me it's looking for it between there. And my guess, I'm just gonna try, I'm not sure which of those is closer, but I'm gonna get as close as I can. And it tells me my third 0 is when X is 5. So that feature, again, is in that calculate menu there. And I'm gonna go label my graph now. So this was 0, 0, this was 3, 0, and this was 5, 0. Now, sometimes our x-intercepts are not integers, right? So we need to follow rounding guidance if we have it, and get those exact values from that calculator. Now, I still do want to find my minimum, my local minimum and my local maximum. So I'm going to go back into my calculator to complete my sketch. So here's my calculator. I'm going to go back into that same calculate menu, second calculate. Okay, and I see that I also have the option to find local minimums and local maximums. So it doesn't really matter which one I do first. I just have to make sure that I follow through with what I say. So let's say I do my minimum first. So my local minimum is over here, right? So again, I have to do a left bound. I have to make sure I move this tick mark to the left of that minimum. And then it asks for that right bound. I have to move it to the right of that minimum. So now I see those arrows. It's looking for the lowest Y value, right? The ordered pair with the lowest Y value between those spots. And then my guess, I need to approximate about where I think it is. So I think it's there. I'm gonna hit enter. And now I can see that exact minimum value. So that says positive 4.1196,299, and then our Y value looks like negative 16.24. So I'm gonna round to the hundredths place, and I'm gonna go put that on my graph here. So that was exactly, if I round to the nearest hundredths, 4.12 and negative 16.24. That's my local minimum. Okay, and then I still have one more value to find. So I'm gonna go back into that calculate menu, so second calculate, and now I'm gonna find my local maximum. So here's my local maximum, and I have to go all the way to the left of it. So here's the maximum that I think it is. I wanna make sure I'm to the left before I hit enter. I wanna make sure then I move to the right. Before I hit enter, I see it's looking between there, which is correct. And then my guess, I think it's about right here. So I'm gonna hit enter. And now it gives me that exact maximum. Again, I wanna emphasize, you don't wanna just move your tick mark. You want to use the calculate feature of finding a maximum, or else you will not get the exact, you won't get the right accuracy. So that looks like, let's see, 1.21, 32.84. So I'm gonna go put that onto my graph. So 1.21, 32.84. So now my sketch is much more helpful to me because intercepts and both intercepts and maxes and mins are gonna be what help me identify all these key features. So the first thing that I'm asked for is the domain and range. Now we see we have this cubic, right, polynomial. So I see that it's gonna continue all the way to the left and all the way down. And then it's also gonna continue all the way to the right and all the way up. So actually for both of these, my domain is negative infinity to infinity, right? All x values are going to eventually be used in this function. And my range is also going to be negative infinity to infinity because all my y values will eventually be used in this function, right? This is going to continue up forever. This is going to continue down forever, so it's going to touch everything. Now, the next one asks us to think about where does the function v of x, where is it greater than 0? So greater than 0, I want to remember, that means that the y values are positive, which means we're talking about where the graph is above the x-axis. That's what we're really thinking about, is if the y values are positive, we're talking about above the x-axis. So I'm going to highlight that. That would be this space right here and this space right here. And then I always have to make a decision about where it actually is on the x-axis. Should I include those or not? And when I'm looking at this graph, it says that it's greater than, not greater than or equal to. So that tells me that we are not including those x-intercepts. So if I want to write this as an interval, I'm talking about going from when x is 0 till x is 3, but not including 0 and 3. So that's why I use my parentheses. And then also, again, so I'm going to use my union. It's positive after 5. So when we go from 5 to infinity, but again, not including 5, because when x is 5, y is equal to 0. And that is not true that it would be greater than if it's equal to. So notice when we're trying to find this, when this graph is positive, we used our x-intercepts to help us identify that interval. All right, now the next question asks us to find where is our function increasing. So remember, that means that from left to right, my y values are getting bigger. So if I trace my graph, where are my y values getting bigger? Well, they're getting bigger right now until I get to this local max, and then they're going to start getting smaller again, right? Because I'm going down. And then right again here at my local min, now it's getting bigger again. So the spots where it is getting bigger, where my y values are getting larger and larger, is all the way up until here, right? And then again from my local minimum all the way here. So I'm going to be using, it looks like, my local max and min to help me with this problem. But remember that I'm only using x coordinates to describe the interval. So I'm using my local max and min, but I'm using x coordinates to describe the interval because we want to describe where or when, which would be the x values. So I am increasing forever from this direction, right? So that's all the way from negative infinity until we get to when x is 1.21. Now I have to ask myself, is it increasing when x is 1.21? We can't say that it's increasing because it's also making a turn to become decreasing, right? So it's really not increasing or decreasing there. So I'm going to use a parenthesis. I'm not going to include 1.21. And then it's increasing again starting over here when x is 4.12. Same idea is happening here, right? We have this point, this is the turning point between decreasing and increasing. So it's not increasing or decreasing, so I don't want to include it. And then it's going to keep increasing forever. So all the way until positive infinity. So there is our interval.